Hey everybody, welcome back. I'm excited to keep working with you on graphing rational functions. We're going to keep building off of the same key ideas from earlier this week and follow a similar pattern with a multiple choice, concept checked, and our traditional kind of worksheet where you can apply your learning and double check your answers with the key. I'm going to really emphasize that you should go back and check my comments on every single thing through distance learning. That's the best way for me to give you feedback and for you to kind of adjust your learning as you go and really become a better independent learner. So thank you so much for what you've been doing so far. And I'm actually going to break this video up into two separate videos so that you can kind of control your learning a little bit better because there's two main topics. So what will those two topics look like, those two videos? The first one's going to focus on graphing rational functions, much like yesterday, just a little bit more complicated versions. So we're going to be finding the asymptotes, the domain range, x-intercept, y-intercept, all that good stuff. And then the second part we'll deal with actually writing a rational function for a word problem situation, much like we did in activity 27. And so that should come back a little bit to you as well. So on that note, here's our word wall from Fluency Test 6, from the parent function with transformations to now dealing with factored rational functions. We've got multiple things in the top and bottom, the numerator and denominator of it. We're going to continue to use the ideas we learned earlier this week on the bottom half in the blue writing about the top, the numerator values. What creates 0 in the numerator will be x-intercepts. What creates 0 in the denominator will be our vertical asymptotes. The holes coming from being in both the numerator and denominator, as well as the horizontal asymptote. So we'll get a chance to practice those skills as well today. Okay, so the plan for the first video here, we're on page 457 for you to follow along in your notes, graphing rational functions. Where first video one is going to look at analyzing graphing rational functions, identifying asymptotes, intercepts, holes, etc. There'll just be an extra step on the early part with having to find a common denominator. And then our second video will do the real world scenarios. So let's look at their example here of adding and subtracting these. You'll notice there are two rational expressions, the 2 over x minus 2 and the 3 over x squared minus 2x. In order to analyze this like we did earlier in the week, we have to combine it into a single fraction. So you'll notice over here on the left, we are looking for a common denominator. So that common denominator is going to be x minus 2. So I have to multiply this first fraction by x over x. So that's our sneaky form of 1. We can then combine 2x minus 3 on the top. The bottom is x minus 2. There's no other factoring here. So I'll have an x-intercept at 3 halves from the numerator. I'll have vertical asymptotes at x equals 2 and x equals 0 from there. It is degree 2 on the bottom, degree 1 on the top. So y equals 0 is going to be my horizontal asymptote. Those pieces can be drawn in. I'm going to recommend you do a highlighter or some type of dash line to draw those in. So even though the book does not have those, you're going to want to include them. So for example, if I just use a quick piece here, x equals 2 would be my vertical asymptote, and x equals 0 as well. And then generally what you do is you're going to plug random numbers in to your simplified expression to get extra points. So for example, plugging -1 in would get me this point down here. So -2 minus 3 is -5. And then on the bottom, I think I get +3. So -5/3. So just under -2 there. If I had the 1.5 for the x-intercept, I would then plug in, say, 1.7 or 1.9 to see where it was going, approaching that vertical asymptote. I could plug in 1 to see where it's approaching on the other side there. I could have plugged in 5 to get that point. There were no holes here because nothing divided out. So my goal is to walk through two of these fully together with you with all the steps involved. Again, I would encourage you to pause and try them on your own before you watch my work to kind of really do it, and then you'll have some more to try and practice with at home. Okay, so here's our first one from page 458, the try these A. We're going to answer those questions to the right as well about crossing the horizontal asymptote. But again, if you go through these steps, these kind of answers, the domain and range will all come clear as you graph the function. So this will be a little bit longer since I'm working through all the steps, but go ahead and pause, try it on yourself to find a common denominator and combine everything and analyze it. But without further ado, if you're ready to see the solution, I'll dive right in. So this is already factored for the most part. So looking at this, my common denominator is going to be x plus 1 and x plus 3 together. So for that first portion, 1 over x plus 1, I'm going to multiply by a sneaky form of 1 in the form of x plus 3 over x plus 3. I'm still subtracting this other portion, 2 over x plus 3, but I'm going to need to multiply by my sneaky 1 in this form of x plus 1 over x plus 1. That allows me to get, multiplying the 1 in here, x plus 3 over my new common denominator minus 2x plus 2 over my new common denominator. And I do that to kind of simplify things and help the next step go smoother. The whole point of that, again, is that minus is going to distribute to both parts. So I actually wind up with x plus 3 minus 2x minus 2 all over my common denominator. And then f of x equals negative x plus 1 all over my common denominator of x plus 1, x plus 3. Even though these are very similar here, they are not going to divide out to create a whole because I have that negative with the x. The negative is not with the whole thing, it's just with the negative x at this point. So I'm going to go ahead and get my graph ready and then pick up the graphing with the analyze with all my asymptotes. Okay, so I've got my graphing grid there to the right. I'm going to start with my intercept. So my x-intercept comes from the numerator being 0. So where does negative x plus 1 equal 0? Well, it happens if x equals 1. So I know at 1 comma 0, I'm going to have an x-intercept. I'll go ahead and plot that in there. What about my y-intercept? Well, my y-intercept is going to be at f of 0. So that's negative 0 plus 1 over 0 plus 1 times 0 plus 3. So in this case, that's 1 over 3. So 1/3. So 0 comma 1/3. I can plot that point. My vertical asymptotes are where the denominator equals 0. So that's x equals negative 1 and x equals negative 3. So negative 1, x equals negative 1. Draw that in again with a highlighter or a dashed line. And then again, x equals negative 3. Okay, so that's a pretty small thing here. I'm going to have to figure out what's happening between those vertical asymptotes. And my horizontal asymptote, the bottom degree is 2, so that's going to be a bigger degree on bottom, so y equals 0 is my horizontal asymptote. So I do cross the y-axis here. So notice that I'm going to cross and then approach that as we go forward here. So let's take a look here at how do I fill in all of these other pieces. Intercepts, y-intercepts, vertical asymptotes, horizontal asymptotes. I care about where it is over here left of negative 3, so I'm going to find out what f of negative 4 is. So that's going to be negative 4 on top, plus 1, all over negative 4 plus 1, negative 4 plus 3. That's 5 on top, negative 3 times negative 1, so 5/3. So negative 4 comma 5/3, so it's 1 and 2/3, so it's right around there. I know it's got to approach my asymptotes there vertically and horizontally, so I get that. I know it doesn't cross because of the x-intercept. So the only x-intercept is over there on the right at 1. I'm interested between what's going on here between negative 1 and negative 3, so x equals negative 2, so f of negative 2 is an interesting point to me. Negative 2 plus 1. All over negative 2 plus 1, negative 2 plus 3. That's 3 on the top, and on the bottom, negative 1 times 1, so that's negative 3. So negative 2, negative 3 is my point here. I'm not going to cross my x-axis here, or that horizontal asymptote, because I don't have an x-intercept there. So it must be approaching these vertical asymptotes down and down. And then over here, I already have 2 points. Clearly, this one's going to be going up towards this asymptote. Here, I'm going to cross the x-axis, and then I'm going to approach it back down. I'm going to go and quickly just find out what f of 2 is, just to see what that point is below. So f of 2, negative 2 plus 1 over 2 plus 1 times 2 plus 3. So that's negative 1 on top, and then 3 times 5 negative 1/15. So that's pretty small there. So negative 1/15 is really, really close there. So clearly I'm already approaching that asymptote. There were no holes. Get something really interesting there. I would recommend typing the original into Desmos to check my work and check your work. And we'll do one more of these. So again, it does cross the horizontal asymptote because there is an x-intercept and the horizontal asymptote was at 0. The domain of this is going to be all the numbers except for our breaks here. So at -3 and -1. So negative infinity to -3, -3 to -1, and then -1 to infinity. The range, on the other hand, that appears to be much more difficult. So clearly everything from 0 to infinity will be up there. Negative infinity up to -3 will be there. That's the bottom portion there. This part right here, negative infinity to -3. And then right now the best I can do here without using Desmos, so Desmos would help me figure out where those minimum points are. But assuming it goes through that negative 1/15 part, I would say right now negative 1/15 up to positive infinity for the upper part. But again, I would have to use Desmos to find the exact minimum value that is right around here. So feel free to take this further and try it. When you're doing it by hand as opposed to a graphing calculator, you've got to do a little bit more just approximation. So there's a big difference between using a graphing calculator and then graphing it by hand. All right, let's look at another one. Okay, and here's our second example. Go ahead and try on your own to combine this and then analyze it fully. If you're ready to watch my explanation, you can go and do it, or skip to the end to see the answer. Or if you're ready to try the homework, just go ahead and move on, and you can check out the second video, which is about looking at word problems. So again, I've got to combine this into a common denominator. My common denominator here is going to include both the x plus 1 and the x minus 1. Therefore, I've got to multiply my first fraction by a sneaky form of 1 in the form of x minus 1 over x minus 1. I'm still adding this 1 over x minus 1. And in this case, I've got to multiply by x plus 1 over x plus 1 as my sneaky form of 1. That allows me to distribute the x squared minus x all over my common denominator plus x plus 1 over my common denominator. F of x is equal to x squared minus x plus 1 all over that common denominator. My function is now x squared plus 1 all over x plus 1, x minus 1. And no other factoring here, so I'm ready to go ahead and start analyzing this and graphing it. So let me go ahead and draw in a quick graphing grid. And start looking at important pieces. So let's first look at our intercepts. For my x-intercepts, it's where my numerator equals 0, x squared plus 1 equals 0. Never, so there are none. There are no x-intercepts. The y-intercept is the function evaluated at 0. Therefore, when I plug in 0, 0 plus 1 over 0 plus 1 times 0 minus 1 equals 1 over negative 1. So 0, negative 1 is my y-intercept. My vertical asymptotes are where x equals, or where the denominator creates 0. So x equals negative 1 and x equals positive 1. So already here, as I'm starting to kind of see this here, there's this middle section. It's clear that I'm not going to cross the x-intercept or the x-axis, so I've got to approach these asymptotes. So this has got to go down, this has got to go down. My horizontal asymptote, notice this is degree 2 on the top, degree 2 on the bottom if I was to multiply it out. This would be x squared over x squared. The degrees match, so it's the leading coefficients of 1 over 1. So y equals 1 is my horizontal asymptote. I'm starting to see why there's no x-intercepts here, because the right and left are going to be kind of those swooping curves to the right and left here. So again, I'm just going to find values here. So 2 is on that right-hand side, so I'm going to find out what f of 2 is. And then on the left-hand side, f of negative 2, and I should be pretty good. So f of 2 is going to become 2 squared plus 1 over 2 plus 1 times 2 minus 1. That's 5 on the top and 3 on the bottom. So 2 comma 5 thirds, which is 1 and 2 thirds. So that's right there. Once I have that, I approach the asymptote and approach the asymptote. Try not to square that off. It should be a nice swooping curve. And on the left, f of negative 2. That's negative 2 squared on top plus 1 all over negative 2 plus 1 times negative 2 minus 1. So I actually get a positive 5 on top, and I get negative 1 times negative 3, so positive 3. So negative 2 5 thirds. I get some symmetry here in this graph. Probably could have expected that. And so there you go. Again, you can check it with Desmos. I'll have the key posted for the homework. Video 2 will feature how to look at a word problem or an analyzation problem with this. But again, the main point is we did the same analysis from Monday, just we had to combine with a common denominator before doing our analysis. Let me know if you have any questions. Drop it in the Zoom help sessions. We'll be assessing your knowledge next week on this on our first Bronco day. So be ready to submit your own video explanations, do some multiple choice, as well as have a take-home version of an assessment. Again, not quite the same as an in-class, but enough for us to get some feedback to you and understand if you're really understanding this stuff next Tuesday. Take care. See you soon. I'd love to help. Feel free to visit the drop-in Zoom sessions that are posted online. And please reach out in any way if I can help you. Have a great day.